One of the things I sometimes quote in my own training is I've had people saying to me, well, I don't need to come on training because I can just read the standard and get on with it. And, it will be great to find people that could do that. But the reality is that everyone benefits from an explanation of what's in the standard, why it's written in a particular way, why it needs to be applied.
Welcome back to episode 2 of the Ingenuity podcast. I'm thrilled to be joined again by Dr. David Ward.
Thank you.
Welcome, David. And in our last episode, which if you haven't heard, I recommend taking a listen, David took us through the origins of functional safety, the foundation of the MIRA consortium and ISO 26262. So today we're going to talk about some of the common challenges that industry faces. David, in your experience, what have those challenges been?
I think one of the first things to say that we learned very quickly is functional safety is always a journey. In nearly 20 years of working with ISO 26262, I've yet to come across a company that has all the processes in place perfectly before they start on product development. The reality is that product development is taking place in parallel with process improvement, and over time the level of confidence we have in claiming that a product's being developed in accordance with the requirements of a standard like 26262 grows. Ultimately, the aim is to have confidence in the product and to demonstrate confidence in that product, underpinned by confidence in the processes that we use to develop and maintain that product, and also confidence in the people and their skills and abilities.
And so you mentioned, we're going to take a little quick trip back, because you mentioned 20 years, but ISO 26262 hasn't been around that long.
That's a really good point, but in fact work started at the international level on ISO 26262 nearly 20 years ago. It took nearly 6 years to get the first version of the standard published. But what was interesting is that pretty much as soon as we knew what the number of the standard was going to be, some vehicle manufacturers were already including it in their RFQs to suppliers and saying you must comply with 26262, even though it wasn't defined at that time what that would mean. So people have been working with 26262 for nearly 20 years. By the way, I'm told that golden number that the standard has, that very memorable number, was purely coincidental. I've always had my doubts about that.
So I've got a funny story about that. In my pre-notes, I read that you'd called it a golden number, and I'm not a mathematician, so I went and Googled what the golden number was, and I was learning about golden ratios and Fibonacci sequence, but you meant it's a memorable number.
It's a memorable number, yes. So it's the kind of number that if you were taking out, a telephone number or something, or personal car registration plate, something that's memorable or obvious, you pay a premium for. Yet it seems that apparently it was just the way the dice rolled or whatever that we got 26262. I remember the committee secretary said, he was really pleased when he saw that was the number, but I'm sure there must have been some pressure to have a memorable number behind the scenes.
Yes, definitely. So it is an easy number to remember, but not necessarily easy to implement. I mean, it's quite a big ask, isn't it? How does that work? What's the kind of expectation of industry?
Yeah, that's another really good question. I think one of the first reactions that we get from people when they're faced with ISO 26262 is they'll say it's big, it's scary, and it's going to be expensive to follow it. So let's take a moment just to debunk each of those myths. So yes, the standard is quite big. It weighs in at 12 parts in total, but it does follow a logical structure. I think I have to say that overall the standard covers all possible phases of the life cycle of a product, starting at the vehicle level, going right down to hardware, software, even custom semiconductor devices. It's rare, but not completely out of the question that one organisation would be following all the stages in the life cycle. So historically, the structure of 26262 reflected the supply chains in the automotive industry, so particular activities that a vehicle manufacturer would do, activities that a tier one supplier would do, and so on. We find in some cases those distinctions have become a bit more blurred, particularly when we look at things like zonal architectures and software-defined vehicle. We also see, particularly, but again not exclusively among startups, that that they will perhaps take more of a complete vertical integration approach to something like the in-vehicle experience, for example. I think in terms of the standard being scary to people, again, a lot of what's in the standard is common sense and good engineering practice, but we needed to codify, we needed to write it down so that there aren't any gaps in what we describe in terms of ultimately being able to generate a safety case. And in terms of whether or not it's expensive to follow the standard, that's often a question I get. What's it going to cost me to develop to the standard? It's a really difficult question to answer because every company's experience, every company's processes are different. And I think it is fair to say, yes, the engineering effort that 26262 requires is going to need more investment. The engineering process that 26262 requires is going to need more upfront investment than a baseline engineering process. But, the old adage is that that's money well spent, because if you think it's going to be expensive to do the engineering right early on, it's going to be a lot more expensive to fix a problem in the field or to deal with a recall or something worse than that.
You mentioned that kind of no one organisation tends to be involved in all of it end to end. But is that where roles like your own global roles, but also roles in independent companies like HORIBA, MIRA are so important?
That's right, yes, because one of the unique benefits we bring is that we can have an end-to-end view. So we're experienced at all levels of the standard. So, for example, a company that's wanting to develop a product and sell it into multiple different end customers, we could effectively act as the virtual vehicle manufacturer and provide a typical set of requirements for a system. Equally, at the other end of the scale, we have good knowledge of what's going on at the level of implementation in the hardware, software, the silicon devices. So even though, say, a vehicle manufacturer is perhaps going to be more detached from that, having the knowledge of the implementation really helps in advising people about what's possible.
And I think that's key, isn't it? I mean, ISO 26262, it's really important, but it's not that magic silver bullet, whatever we call it. It's not that magic answer, is it? It's all about the implementation.
It's all about the implementation, yes. And as one of the long-term collaborators in developing the standard once said to me, and has said quite publicly, one of the really important things about applying 26262 is to engage your brain at the start of the process and to keep it engaged. We touched last time on the fact there's a tendency for people to want to see these things as recipe books or just a checklist that they can follow. One of the first questions I always say to people that come to me wanting help is, do you want to comply with the standard or do you want to develop a safe product? Because they're not always the same thing, but clearly following the standard is a big help to develop a safe product, but we have to know that we've applied it in an appropriate way. And I think one of the really important aspects of that is the emphasis that the standard has on a safety case. So not just that we claim that we follow the standard, but actually that we build up arguments about why we did things in the way we did, what was the rationale for the engineering process. 26262 itself is quite light on what should go in a safety case, what that looks like. But again, MIRA has stepped in here and published some guidelines on how to structure an argument-based safety case for automotive applications. And again, it's pleasing to see that some of the principles that are in a document like this one are now being picked up in some of the newer standards that we'll talk about in the next episode.
Yeah, I was going to say, I do a bit of a spoiler alert, but as you said, I think that importance of the kind of implementation and the safe product are going to become increasingly important in the future.
That's right.
We'll talk about that in the next episode.
Yeah.
So from the perspective of our listeners, just benefiting from your expertise over many years in functional safety, what are the important things that people should keep in mind?
Right. Well, there's a number of things that, if you like, are the sort of top principles in terms of adopting 26262 and ultimately using it as part of the process to develop a safe product. The first is to install and maintain a safety culture in the organisation. So how we define the scope of the organisation can be flexible. For some companies, it's literally the whole organisation. For others, it might be a particular business unit, and that's okay. But we need to have a culture we need to have a culture in the company where everyone sees safety as their responsibility. Everyone realises that they have a part to play. And I think one of the really practical aspects of that, and something that's not directly mentioned in 26262, is that someone in the senior leadership of an organisation needs to take ownership and responsibility for functional safety. It needs to be seen to be led from the top. People need to know that it's an organisational value to do this and do it in the right way. I think linked to that is that means that a company needs to have processes in place for functional safety. I think one of the important lessons we've learned over many years is don't just ride into a company and say, here's a bunch of processes, these are now your functional safety processes, because with the best will in the world, people won't follow them. Instead, we very much encourage starting with where people are at. Every company has a process, even if they're a startup organisation. Everyone is doing something, so we always start by looking for the good in what's being done and building on that to set in place the processes that are required for functional safety. Another aspect, we referred to that at the beginning, is confidence in the people. So the technical term that's used for that in the standard is competency management, and it's really important to establish and maintain the competency and the skills of people that are going to work on projects in accordance with 26262. Training and skills development is an important part of that, but it's by no means the complete story. It's not enough just to collect a bunch of certificates saying you've been on a training course. You have to have the practical knowledge of applying it, the experience, being guided by more experienced practitioners who can help you navigate some of the more difficult challenges and difficult questions. Another really important aspect is that we need to walk the talk. It's not enough just to put the processes in place and say, look, our company's now set up to develop things in accordance with 26262. You have to be following those processes. They have to be lived, if we can put it that way, and not just be theoretical or things that are on a bookshelf. And related to that, we have to make sure that, and again, this links back to the need for a safety culture, we have to make sure that people are provided with the resources and tools to execute those processes. We also need to make sure those processes are followed fully, so we don't end up with gaps or things that, we ran out of time or we couldn't do that. And then the last step is that one of the important aspects in standards like 26262 is the subject of assurance. So how do we demonstrate that we've developed a safe product? And that demonstration is for our own confidence in what we've done, but it's not simply patting ourselves on the back. It's also, there's a role in 26262 for independent reviews of activities. That covers independent reviews of some very specific activities, as well as a global requirement for an independent person to review the work that's been done. So that's another really important aspect, and having something like a well-structured safety case really helps with that process of demonstrating assurance. And again, having a strong safety culture means that, people shouldn't be afraid of someone like myself coming in as an independent assessor. Again, I remember one of the first assessments I was involved with, the poor person that I went to have a chat to was visibly shaking when I came to talk to him about his work. And I said, you don't have to worry. It's not that kind of adversarial discussion. So, but it's really important that as part of a safety culture that organisations and the individuals within those organisations understand that that's an inbuilt part of the process, and it's nothing to be ashamed of. It's not a personal criticism if an independent person comes in to review what they're doing. I did say finally, whilst we quite often focus this on a particular organisation, we have to bear in mind a lot of this can fall through into managing supplies, for example. So some of the process requirements for functional safety can go beyond the engineering departments. Quite often it might be seen as, quote, just, unquote, an engineering issue to deal with, but things like competency management, for example, might be part of a personnel management process. How we cascade requirements to suppliers and ensure that they're bought into those and delivering them might be handled by a supply relations department and so on. So it's important to remember, and again as part of a safety culture, that functional safety is something that can address all aspects or many aspects of an organisation, not just the people creating the systems that functional safety is applicable to.
Yeah, definitely. I mean, I think that's certainly what's come across from this episode, but also the previous episode, that how important safety is as a collaborative consortium effort, really. And I think
that's right.
It's about the critical friend coming in and being able to say, no, this needs to improve. We need to look at these areas.
That's right.
That's so important. I wondered if we could touch on the skills and the competencies just
yes, of course,
briefly as well. Because I know from our conversations that you do a lot of work with the MIRA Technology Institute and you work with our further education and higher education partners. So what does good look like in terms of skills for functional safety?
That's a really good question. I think it probably covers a number of areas. The first is clearly to have foundational skills. And I think whilst there are some examples of this we could probably do with more, that there should be some kind of introduction to functional safety awareness in higher education courses. I think if we take the related discipline of cybersecurity, for example, that's something that everyone's latched onto, and rightly so, and there are degree courses and so on related to cybersecurity. We find there are less courses related to functional safety, but in some ways we can build on a foundation of things like systems engineering, for example. So if people are coming out of higher education with good analytical skills, with a good mindset of systems engineering thinking, then we can work with that and develop that. Clearly, we need training specifically on functional safety. We need people to understand the principles of functional safety. So in our own training courses, we don't go straight into saying, here's 26262 and this is what it says. We actually cover some foundational material so people understand why it's important as a discipline and how it relates to some of the wider engineering activities. Clearly, then we would instruct people on 26262 and what it means. And again, I think as we've already hinted at, that needs to be practical, not just theoretical. One of the things I sometimes quote in my own training is I've had people saying to me, well, I don't need to come on training because I can just read the standard and get on with it. And, it'll be great to find people that could do that, but the reality is that everyone benefits from an explanation of what's in the standard, why it's written in a particular way, why it needs to be applied. I think that the final aspect is something that's really, really important and is quite often missing, is the domain knowledge as well. So you can't apply some of the processes in 26262 like the hazard analysis and risk assessment in a vacuum. You need to have the domain experience. So if you're doing a hazard analysis on a braking system, for example, you need knowledge of things like vehicle dynamics and behaviour of braking systems. And again, one of the benefits of working with an organisation like ourselves is we can bring in those skills from our wider team at HORIBA MIRA. But I think it's really important for people that want to be effective functional safety engineers that they build up that domain knowledge, and they recognise as well that knowledge develops over time. There's some really useful competency frameworks that have been developed by people like the Health and Safety Executive in the UK, for example, that really point out in a nutshell that as far as competency is concerned, you can never stand still. You're either walking forwards, continuing to develop your knowledge and abilities, or you're sliding backwards because the world has moved on and you haven't.
Yep, absolutely. And we're going to touch on that and the future in the next episode. But for now, David, thank you very much for joining me and taking us through ISO 26262.
Thank you.
Thank you.